There will not be a lot of proofs on your test. Let me tell you exactly how many so you can kind of be prepared for that up front. There will be one all by yourself proof, okay? But it will be worth 4 points. So you don't want to just blow it off, because if you miss a few points here and a few points there, that could be the thing that drops your grade. I'm not going to give you a lot of proofs on the homework. I'm going to advise you, if you're studying for your test, the best place to look at the proofs to study for your test is going to be the ones we do together in the notes. So practice those over again. Look at your theorems. Look at your postulates. Those are going to be the things you want to focus on. But your homework's not going to be proof intensive. Like I said, there's only one on the test. So focus on the ones we do in the notes when you're studying, okay? And notice, what are we trying to prove here? Okay, that two triangles are congruent, right? We had 5 ways to prove triangles congruent we learned last semester. What were our 5 ways to prove triangles congruent? I heard angle, side, 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 angle, side. I heard angle, angle, side, and hypotenuse, leg. What are the 2 ways we cannot use to prove triangles congruent? ASS, don't cuss at me and don't cuss at me backwards. And what's the other way? Angle, angle, angle. Remember, this is like, we're going to use angle, angle, angle next chapter to prove that shapes are similar. Angle, angle, angle can be used to show that the shape has gotten bigger or smaller, but it doesn't guarantee that the side stayed the same length. It's kind of like a blueprint. Your angles on your blueprint stay the same when you build your house, but your house walls get bigger. So angle, angle, angle does not prove triangles congruent. Okay, so these are our 5 ways. We're going to look for one of these 5 ways to prove these 2 triangles congruent. We always start by setting up a T-table, which I should have given you in the notes. Left side is statements, right side is reasons. We always start with our given, usually as our very first statement. So what are they telling us about this picture? It's a parallelogram. So ABCD is a parallelogram. And the reason is given. And I left on the board over here our 5 properties of a parallelogram that are on your property sheet so that we can use those as we're working through today. The next thing I would do is I would focus on which triangles am I trying to prove congruent. AEB and CED. That means we're trying to prove this left triangle congruent to this right triangle. Is everybody okay with that? Okay, so we have to use these properties or anything that we learned from last semester to try to show that these 2 triangles are congruent. So what's something that you think we could use here? Okay, so the first thing is nothing to do with the fact that it's a parallelogram, but we do remember that vertical angles are congruent, and so this angle here is congruent to this angle here by the vertical angle theorem. Is everybody okay with that? Any questions on that part? Okay, name these angles for me correctly. Okay, I heard angle AEB is congruent to angle, now be really careful. Okay, AEB, according to this congruent statement, should be congruent to CED. So what's going to happen here is these 2 triangles are not just folding on top of each other, but one of them's flipping over, right? Before it matches. So AEB should be congruent to CED, AEB, CED. This has to flip over before they flip again. And Devin said that was the vertical angle theorem. Make sure you're spelling vertical correctly. Okay, that's one angle marked congruent. In order to prove them congruent with angles, we either need another angle and a side or 2 sides. What else do we know if it's a parallelogram? Okay, in a parallelogram, our opposite sides are congruent. Which 2 sides would be helpful to be congruent here? Okay, AB and CD. So we can say that AB is congruent to, and technically AB is going to match up with CD. And the way you're going to state that, it's not a theorem, it's not a postulate or anything like that. You're just going to write it out. In a parallelogram, opposite sides are congruent. It's technically wrong because when you write that, I mean, it is true, but it's technically not correct notation because vertex A does not land on vertex D. And so when you name two things congruent, you're saying that the parts match up. But for these two triangles to match up, they're not folding straight across. This one has to flip over first for them to match up. And the one thing that I always use is I use this congruent statement just to help me. This says that AB should match up with CD. So if I use that, it's going to help me not make a mistake when I'm naming my parts. Okay? All right, so you're just going to put N, A, and you can use symbols anytime if you want to. So I'm just going to draw a picture for a parallelogram. In a parallelogram, opposite sides are congruent. So you're just naming the property. The only time you won't name the property is if it's the definition. And then you'll just put definition of a parallelogram. All right, that gave us a side. We have an angle. What else can we use? Diagonals bisect each other. The diagonals bisect each other, so what part do we need to be congruent to help us? If I use BE, what's it going to be congruent to? DE. Is that going to be enough to prove that it is a parallelogram? Or excuse me, that the two triangles are congruent? No, why not? What is that? Okay, angle side side. So we're going to have to use actually both diagonals. So we're going to have to say these are congruent as well. Do you agree? Okay. Did I really need then this one that said opposite sides are congruent? No. So, ooh, holy cow, that got big. So I really don't need the step number 3. Because if I use that the diagonals bisect each other and I mark both of them, what am I going to have here as far as why these two triangles are congruent if I get rid of this? Side, angle, side. So watch for that. You don't want to list every single thing you know. You just need enough to prove what you're trying to prove. This was true, but it won't be enough to just say these two sides are congruent because that's angle side side. And it won't be enough to say these two are congruent because that's still angle side side. So we have to have both, so we really didn't need this piece. Does that make sense? Okay, so I'm going to delete step number 3 and write a new number 3. And I'm going to put that BE needs to be congruent to what? DE. And since it's the same reason, I'm going to go ahead on the same statement and write the other two parts that are congruent. So that was AE needs to be congruent to what? What is it? CE. And so my new number 3 reason will be in a parallelogram, diagonals bisect each other. So you're just naming what the property is. And now we have enough to prove the two triangles are congruent. So statement number 4, I'm going to write up here so you can see it better, is just what we're trying to prove. Triangle AEB is congruent to triangle CED. And what's our reason number 4? Side, angle, side. So it's exactly what we did last semester, except now we've got these properties to use to try to get us there. So you are going to have to think about all those things you learned last semester, like Devin helped us remember vertical angle theorem. If you get stuck and you're having trouble, flip to the back of your book, go back through your postulates and theorems, okay? But again, your test will be similar to the ones that are in the notes. So study the ones in your notes before the test. Okay. look at the next proof. We have one more that we didn't get to, and that's this one. Take a minute and just kind of look over it so you can kind of get an idea of what you should do, and then we'll talk about it. Okay, let's start talking through it. So first of all, we need to write down our given. These two are parallelograms. I'm going to save myself time so I don't have to rewrite all this since this is just my notes, and I'm just going to kind of circle all of this and put it right here. And given. Now on your homework, obviously, you'll have to write it all out. So we have each of these shapes are parallelograms. They tell us that H and M are collinear. Why would it be important for them to write that H and M are collinear? Okay, it lets us know that they're on the same line so that we don't think that JM is maybe curved downward somewhat. It may, just so we know for sure that this is a straight line. It could be curved just a little bit. It could be that this is going off just a degree or something the other direction. So they're just letting you know for sure these are on the same line, okay? And the same for KN. It's a straight line. That's the only reason that they write that, just so you can be confident. All right, we want to prove this angle here is congruent to this angle here. That's our goal. This one's a little bit harder. Any suggestions or ideas how we might get there? Jonah? Okay, great idea, but I'm going to stop you real quick. I do see where you're going. The only problem with that is the transitive property was either of equality or of congruence. We don't have one that says if these two lines are parallel and these two lines are parallel, then these two lines have to be parallel. There should be a theorem to that. I'm not sure that we've learned a theorem that actually says that. And yeah. So I do get here's where Jonah's going. He's saying that if this line's parallel to this line, since these are collinear, that's the same line, and we know this line's parallel to this line, so we should be able to say these two lines are parallel, right? But I don't think we've learned a theorem that says that. It's true, but we haven't learned that theorem yet. We could write that out. I would accept that if you did. If you said that if these two lines are parallel and these two lines are parallel, then these two lines have to be parallel. How would that help you from there? Angle H is congruent to angle M. I like that. Since we don't have a technical theorem that we've learned, I'm going to show us a different way, but I would accept that if you wrote that. So I want to make sure everybody is with Jonah. If we do it the way you say, I'm going to write it over here on the board so we can see how that would look. We could say that GH is parallel to what? NJ. I'm going to go ahead and say NK, just because we know that whole line is collinear. These two lines are parallel. Why are these two lines parallel? But we have to write it as in a parallelogram. Oops, not triangle. Opposite sides are what? Not congruent, parallel. That's what we're trying to prove, that they're parallel. So here's one option. We could say these two are parallel because in a parallelogram, opposite sides are parallel. Then we could go back to the next one that Jonah said and say that NK is also parallel to ML. Same reason, right? In a parallelogram, opposite sides are parallel. So I'm just going to write that as the same statement, same reason. Then what he's saying is because they're both parallel to the same line, they have to be parallel to each other. So you would have to write that out. If two lines are parallel to the same line, then they are parallel to each other. And I don't think we learned a theorem that says that, but that is true. So I would accept that if that was your thought process. So these would go together, and then we could say that GH is parallel to ML. Is everybody okay with that? It's not the transitive property because that's only of congruence or of equality, but it is using that line of same kind of thought. If these two are parallel, then that would mean that angle H is congruent to angle M. And why again? It is alternate interior angles here. Perfect. Very good, Jonah. Questions on that idea? Okay, there's another way we could approach it where we don't have to use the two parallel lines parallel to the same line. Jackson? NJH, sorry. Uh-huh. Mm-hmm. Okay, your thought process is correct, but again, I don't think we have a theorem that says if these two angles are congruent, then these two have to be congruent. But you are on the right idea. We can use that congruent supplements theorem, but it says it a little bit differently. I want to make sure everybody understood where Jackson was coming from, though, because this would be great if we were trying to prove G congruent to L. If these two are congruent, and these two are congruent, and these are congruent because of the vertical angle theorem, would you agree that G and L would have to be congruent using transitive property? Okay, because it could highly likely be something like that on your test. So these two congruent by opposite angles are congruent. These two congruent by opposite angles are congruent. These are congruent by vertical angle theorem. And then transitive would say these two have to be congruent. Okay, congruent supplements theorem would be a great theorem to use, but it says if two angles are supplementary to two congruent angles. So we need two angles. We're trying to talk about these two angles here. We need them to be supplementary to two angles that are congruent. Do you see an angle that H would be supplementary to and that M would be supplementary to that are also congruent to each other? J. Do you guys agree that these two angles are supplementary and that these two angles are supplementary? And we know these two are congruent to each other by vertical angle theorem? So then congruent supplements theorem would say these two have to be congruent to each other. Is everybody with me there? Okay, I'm going to write it down so you have it in your notes. So put this down there with me. So you could either go Jonah's route or you could go this way with Jackson's idea of congruent supplements. So we would need to first say that these two angles are congruent by vertical angle theorem. So let's name those. Angle what? NJH is congruent to angle, be careful, KJM. And that was the vertical angle theorem. And then what did we say from there? What was the next thing that we talked about? We talked about what word? Supplementary. Which two angles are supplementary? H and J. Using our properties, we said that consecutive angles are supplementary in a parallelogram, right? So the next statement we would need is angle H and angle, can we call it J? No, so we would have to go back and name it like we did before. NJH are supplementary. And for the same reason, which other two angles were supplementary? KJM and angle M. So the ones I circled in red, we're just listing that those are supplementary. And remember that new for this chapter, the way you write that out is just to name the property that you're using. So the reason is going to be in a parallelogram, consecutive angles are supplementary. Make sure everybody is with me. I'm kind of worried about it. You guys understand where we got that? Questions? Okay, so we've said these two are supplementary, these two are supplementary, J is congruent to J, so that means if these two angles are supplementary to congruent angles, these two angles have to be congruent. And that was the congruent supplements theorem. So number 4 would be what we're trying to prove. Angle H is congruent to angle M. And the reason would be that congruent supplements theorem. Okay, 2 proofs that could be similar to what's going to be on your test. 2 different ways you could have worked this proof, one on the board, one on the smartboard. And then we also talked about a way we could prove G congruent to L, which could be on your test. Any questions on these 2 proofs that we looked at? Okay, let's move on to 6.3. 6.3 is basically just the converse of 6.2. Okay, so 6.3 is going to ask you to prove that it's a parallelogram instead of telling you it's a parallelogram. Think back to chapter 2 with me. What did converses do to if P then Q? Switched it, right? So what did it say? So if P then Q, what did a converse say? If Q then P. We didn't add in the words not for converse, that was inverse and contrapositive. Converse just switched your hypothesis and your conclusion. So here's what 6.3 does. 6.3 is going to talk about the converses of this. It's going to say, instead of if you have a parallelogram, these things are true, it's going to say if one of these things are true, then your shape must be a parallelogram. So it's just going to switch it. Instead of knowing it's a parallelogram first, they're going to ask you to prove it's a parallelogram. Okay? And there's going to be 6 ways that you're going to be able to prove it's a parallelogram. We're going to list these on our property sheet. 4 of them are going to be exactly the same as these up here. So it's going to be pretty easy. So on your property sheet, I want you to title this Ways to Prove It's a Parallelogram. And I'm going to sort of follow the notes, but I'm also going to just kind of follow what we have here on the board. Okay? So one way you can prove you have a parallelogram is by the definition of a parallelogram. What was the definition? What did it say? A parallelogram has what? Opposite sides parallel. The only thing you have to be careful about to prove it's a parallelogram is that you have both pairs of opposite sides parallel. If you have both pairs of opposite sides parallel, you can definitely say it's a parallelogram. That's enough to prove it's a parallelogram. You have to have both pairs. One pair being parallel is not enough information. Okay, what else did we know about the opposite sides of a parallelogram? Not only are they parallel, but what else? They're congruent. That's going to be in your notes, so I'll try to point out where these are, by the way. The definition, obviously, is a way to prove it's a parallelogram. Definitions are always biconditional. They go both directions. The next one is if both pairs of opposite sides are congruent, which was exactly what we had over here, opposite sides congruent, but again, it has to be both pairs. So if both pairs of opposite sides are congruent, then that's enough by itself to prove that it's a parallelogram. So it's really not much new, right? It's just the same thing. We're just writing it the other direction. If these two things are marked congruent, both pairs of opposite sides, I know it's a parallelogram. Okay? I'm going to try to stick to the ones that don't change, and then I'll come back to the ones that are a little different. So another thing that we knew about them is that the diagonals in a parallelogram do what? Bisect each other. So if your diagonals bisect each other, that's enough to prove it's a parallelogram. So number 3, if the diagonals bisect each other, and again, I should write down both diagonals bisect each other. Just having one diagonal bisected is not enough information. If both diagonals bisect each other, that's enough to prove it's a parallelogram. That was this one here in your notes. Go back. I think I skipped one on this page that also is the same. What was something we knew about the opposite angles? Opposite angles what? Are congruent. So if you have both pairs of opposite angles congruent, that's enough to prove it's a parallelogram. Again, you have to have both pairs. So none of these 4 are any different than what we already knew. We're just going backwards. If one of these things are true, I can say it's a parallelogram. You only need one of them to be true to say it's a parallelogram. The next 2 things we're going to write down are a little bit different than what we have over here, but close. So the 5th way you can prove it's a parallelogram is similar to the one that we haven't listed, and that is consecutive angles are supplementary. This is saying, though, that all 4 consecutive angles are supplementary. If I have this as 60 and this is 120, is that supplementary? Yes. If this is 120, are these 2 supplementary? Yes. I don't really need to know this 4th angle. What did we learn about all 4 angles in a quadrilateral? They have to add to equal 360. So if this is 120 and this is 120 and this is 60, what does that add to be right now? 300. And if it's 300, what does this angle have to be then? 60. So they're going to write this down as a little bit of a shortcut. You don't have to know that all 4 consecutive angles are supplementary. You only need to know that one angle is supplementary to its 2 consecutive angles. So you really only need to know 3 angles in your picture. Let's say that again and draw it again up here. So if this is 50, what does this angle have to be? 130. And what does this angle have to be? 130. So if they give you this in a picture and they say, is this a parallelogram? Even though you don't know this angle, you can say yes. Because as long as one angle is supplementary to both of its consecutive angles, that's going to be enough to prove it's a parallelogram. because ultimately this angle is going to have to be 50 also, which means all of them turn out to be supplementary. Does that make sense? So they're going to shorten it a little bit, and they're going to say all you need is one angle supplementary to both of its consecutive angles. If one angle is supplementary to both of the angles that are next to it, that's enough to say it's a parallelogram. So just like in both of these examples, if I knew these three angles, I would have enough to say that is a parallelogram. And then the sixth and final way is not a sixth property. It's not a new property. It's just a shortcut to one of these five. So here's the sixth way you can prove it's a parallelogram. There's 6 ways. Sixth way says if you have one pair of opposite sides, but that one pair has both properties, they are parallel and congruent. Be careful, it has to be the same pair. So if I look at my picture, notice this side is parallel and congruent to this side. That's enough to prove it's a parallelogram. So if one pair of opposite sides are parallel and congruent. But again, it has to be the same pair, parallel and congruent. They'll try to trick you, and they'll do this. Is that enough to prove it's a parallelogram? No, because you don't have both pairs opposite sides parallel, and you don't have both pairs of opposite sides congruent, and that you have a different pair congruent than is parallel. So it has to be the same pair has both properties. Any questions on the 6 ways to prove it's a parallelogram? Yes, we're going to talk about rectangles later, but right now we're trying to say, is it a parallelogram? Then we're going to get more specific and say, if it's a parallelogram, could it be a rectangle also? Could it be a square also? Could it be a rhombus also? So we're going to get there. This is not enough to prove it's a rectangle by itself. It's enough to prove it's a parallelogram. Then you'll have to go a step further to get that it's a rectangle. Okay? All right. So the rest of this is just going to be applying these to your problems, okay? So look at this example, and what's a key word here that you see? Here's someone saying it. Show. It's not a proof, but it's where you got to show all your work. Okay, so we're going to go through these pretty quickly, but I'm going to remind you that you have to show detailed work. If you just write a bunch of numbers down, I'm not going to give you credit. So label what you're doing. Show this is a parallelogram if A is 3 and B is 9. You have 6 ways to show it's a parallelogram. Which method could we use here based on what they've given us? Okay. Number 2, both pairs of opposite sides are congruent. We're going to have to plug in these numbers and show that the opposite sides are congruent. And you do have to show your work. Label what you're finding. So let's start with KL. Plug it in. 5B plus 6. What's going in for B? 9. And I'm going to write pretty quickly, so try to follow with me. Slow me down if I go too fast. What's 5 times 9 plus 6? 51? Okay, so KL is 51. If I were you, I would go and do the opposite side just to be consistent, so we're trying to show what we're finding. So JM would be next. 8B minus 21. Plug in 9. What's 8 times 9? 72 minus 21. 51. And then I would tell me, what did that just show? It showed that KL is what? Congruent to JM. Don't forget your notation. You should have line segments above them if you're saying they're congruent. You should not have line segments if you're telling me what they're equal to. Okay? So right now we've got one pair of sides congruent. We're going to do the same thing to show the other pair congruent. So we have 15A minus 11 is equal to, oops, I should have wrote KJ first. KJ equals 15A minus 11. Again, don't just write down a bunch of numbers. What does that go with? KJ. What's going in for A? 3. 15 times 3 is 45. Minus 11 is 34. Then find LM. 10A plus 4. What's A? 3. What's 10 times 3? 30, and 30 plus 4 is 34. Yeah, I did that really fast. Are you with me? If those are equal, then what does that mean about KJ and LM? They're congruent. So KJ is congruent to LM. And then I'm going to expect you to do one last thing. This will be on your test, just like this. One last thing you need to tell me is what property proves that it's a parallelogram now. You've shown all this work. Which property did we use? Both pairs of opposite sides are congruent. So you'll write down both pairs of opposite sides are congruent. So you only have 1 2-column proof on your test, but you're going to have problems like this where you have to show your work, label it, and back it up with the property. Okay? Not 2 columns where you have to justify every single step. Any questions on that one? Okay, look at the next one. It's very similar, but what does it give us in this picture? Angles. How many angles? 3. If all I know are 3 angles, can I use the idea that both pairs of opposite angles are congruent to prove it's a parallelogram? No. Biggest mistake I usually see on the test is students get to this problem and they find these 3 angles, and then they say that angle P has to be the same as angle R, so both pairs of opposite angles are congruent. Angle P does not have to be the same as angle R unless it's a parallelogram. If you're trying to prove it's a parallelogram, then you don't know that these are the same. Are you with me? So be careful. If I know these 3 angles, could I find angle P? Because what has to be true for every quadrilateral? They have to equal 360. So if you try to use both pairs of opposite angles are congruent, you would have to go a step further first and solve for P by adding these up and subtracting it from 360 to get the measure of this angle. And if you're showing, you would have to show all that work. Does that make sense? So if you don't want to go to that extra effort, instead of saying opposite angles are congruent, what could we use to prove this is a parallelogram? Because we don't have to have all 4 angles for them to be consecutive supplementary, right? We said we just need 1 angle supplementary to both of its consecutive angles. So if I can find angle R, and R and S are supplementary, and R and Q are supplementary, that's enough to prove it's a parallelogram. Does that make sense? Okay, so now we have to find all that. So let's do it real quick. Correct notation, we need to find angle Q, so it's measure angle Q equals. Then we're going to find the measure of angle R. Then we're going to find the measure of angle S. And then we're going to see if those consecutive angles are supplementary. Okay? So Q is 6y plus 7. Again, make sure you're labeling and showing your work neatly. What's going in for y? 6.5. The great thing is now you get a calculator. And by the way, sometimes your tests are going to be divided, part calculator, part no calculator. I do want to warn you about that as we go through this semester. You won't always get a calculator, but I'll give you a warning like, hey, on the test, these are the things you're going to have to know without a calculator. But this test is all calculator. Okay, so this chapter, you'll get a calculator for the whole test. All right, what do you get? I got 46. Does somebody agree with Brendan? Yes? Okay. So 46 degrees. Measure of angle R is 15 times x minus 16. What's going in for x? 10. What do we get for angle R? 144 or 134? 134. Don't forget your degree symbols. And then angle S is 8y minus 6. And y was 6.5 again. And what do we get for angle S? 46. Okay, and then you need to show me what you're trying to prove. So what do we want to be true here? Okay. R needs to be supplementary to Q, and R needs to be supplementary to S. So when I add the measure of angle R plus the measure of angle Q, I get what? What is 46 plus 134? 180. And then when I add angle R to angle S, 134 plus 46 is also 180. So show what you're trying to prove, that those angles are supplementary. And every single time, back up your work with the property. So you're going to list your property at the end of your work. And the property was if one angle is supplementary to both of its consecutive angles. So one angle is supplementary to both of its consecutive angles. And it keeps picking off what I'm writing. Am I being clear enough about what I expect to see? Because I don't want you to miss points on your test because you didn't show enough work. Label, show your work, back it up with the property. You will have questions just like this on your test. The next two examples you're going to see in your notes are much quicker. They are just simply going to give you a couple pictures. You're going to decide are they parallelograms, and you're going to justify it with the property. So you and your partner go ahead on the next two examples, decide if you think they are parallelograms. If you say yes, tell me which property. If you say no, tell me why not. Okay, so on your papers, go ahead and do it. Okay, hands up if you say yes, this is a parallelogram. Great. Which property did you use? Very good. If one angle is supplementary to both of its consecutive angles. So you would say yes, because one angle is supplementary to both of its, that should be consecutive, not corresponding. Both of its consecutive angles. Okay, so you'll write it out. Any questions on this one? All right, again, do not say that opposite angles are congruent unless you go a step further to show me that you added all these together and subtracted them from 360 and solved for this angle, and then you could say the opposite angles are congruent. Okay, so you have to show that work if you use that method. All right, this one, hands up if you say yes. Hands up if you say no. All right, what's wrong? Okay, both pairs of opposite angles, where's it at? Both pairs of opposite angles need to be congruent, and they only give you one pair. So when it says justify your answer, if it says that, you need to say no because you need both pairs of opposite angles congruent. Okay, and you don't have that. You only have one pair. So you need both pairs of opposite angles congruent. Jonah. Okay. All right, I passed out a sheet of graph paper because the next thing you're going to have to do is on the graph. Again, this semester, I would encourage you to make sure you always have some graph paper in your binder. If you don't, before you leave today, grab a couple sheets. Please don't grab 20. Grab a couple, put them in your binder, okay? I should have passed out 2 to everybody. If you didn't get one, jump up and grab one. Look at the next example, and then I want to warn you about what it's going to look like on your test. And I'm going to do this every section to make sure you're with me. On your test, it will not say, show that this is a parallelogram. On your homework tonight, it will. On your test, it's going to say, what kind of quadrilateral is this? And by the end of this chapter, you're going to know 6 quadrilaterals. So you're going to have to investigate with distance formula or slope or both, and you're going to have to prove to me what kind of shape it is. Okay? So on the homework, as we're learning, we're just learning one shape at a time, so it's going to look a little different. But by the time you get to the test, the directions will say, what kind of quadrilateral is this? Show work to back up your answer, and it's going to say back it up with a property. And so to get full credit, you'll have to show me all your work. You'll have to back up your work with a property. Okay? This just says show that it's a parallelogram. So that means you could choose any of these 6 ways to do that. But it actually goes a step further and says you have to use theorem 631. That's in your book. I don't know what 6-3-1 is. I'm pretty sure it is this one. So follow the directions on your homework. If it says use 6-3-1, look at your notes in your book and see which one of the 6 ways was that. Otherwise, if it doesn't specify, you can choose any of these methods to show it. Okay, let's talk about how I might show these then. So if I want to show both pairs of opposite sides are parallel on a graph, how could I show both pairs of opposite sides are parallel? Slope. What has to be true about the slopes? Same. So I would use slope formula, and I would show that these have the same slope. Does that make sense? Okay, how could I prove opposite sides are congruent? Distance. I would have to use my distance formula and show that they are the same. Okay, diagonals bisect each other. If diagonals bisect each other, where will they cross? Be more specific. If 2 lines intersect so that they're bisecting each other, what is this point going to be? The midpoint. It's going to be the midpoint of this line segment, and it's going to be the midpoint of this line segment. So if you want to prove that 2 diagonals bisect each other, you need to find their midpoints and show that they have the same midpoint. Does that make sense what I'm saying? If I have a parallelogram and the diagonals bisect each other, then that means that they have to have the same midpoint. Yes, are we good? Okay, so that's an option. There's not a way to show that both pairs of opposite angles are congruent on a graph. So we would not be able to do that graphically. There's not a way then to show that both pairs of consecutive angles are supplementary on a graph. So we wouldn't be able to use 4 or 5. 6 would allow us to use a little of both formulas. We could show they're parallel with slope, and we could show they're congruent with distance formula. So if you want to practice both formulas, you could show it this way. Are you guys with me? Okay. Since this says use 6.31, I'm going to go ahead and we're going to prove it doing 631, which I'm pretty sure was this last way. So I'm going to shift to the dot cam. We're going to do it together. Graph your shape if you haven't already. And again, I'm going to be very picky on the test to give you full credit that you have shown detailed work. So be very careful that you are showing lots of detail. All right. And obviously, make sure you're graphing it correctly. If you make one mistake graphing it, it's going to mess everything up. Does my graph look like your graph? Except maybe yours is a little better connected. Okay. So we have this shape, ABCD. We've got to show that it's a parallelogram by proving that one pair of opposite sides is both parallel and congruent. Which pair of sides do you guys want to use? AD? Okay, so we're going to find the distance of AD, and we're going to find the distance of its opposite side, which is BC. And we're going to prove that they're congruent. And then we need to find the slope of AD and the slope of BC and show that those are congruent. If they have the same slope, then that means that they're parallel. And this is what I mean by showing your work neatly. Make sure you're labeling what you're writing down on your paper, that you don't just have a bunch of numbers, okay? So let's start with distance formula. Do you guys remember your distance formula? Square root of x2 minus x1, and then we square it, and then we do the same thing to the y's. y2 minus y1, and we square them, and we add them together and take the square root. So let's do that for A and D. What's going to go in for the x's? You've got the notes in front of you there. Sorry, say it again, Sean. Okay, so 2 minus 1 squared plus what's going to go in for the y's then? 3 minus 1 squared. Simplify and show your work. Keep your square roots. Make sure your work is correct all the way down. What's 2 minus 1? 1 squared plus 2 squared. All right, I wrote those two close together. So what is 1 squared? 1 and 2 squared? 4. So what's 1 plus 4? 5. So we have the square root of 5 for AD. Now we're going to do the same thing for BC. B was 6,2, C was 5,0. What's going to go into my distance formula here? Talk to me, guys. 6 minus 5 squared plus 2 minus 0 squared. What's 6 minus 5? 1 squared. What's 2 minus 0? 2 squared. And so we end up with the square root of 1 plus 4, which is the square root of 5. Again, I wrote those two close together. And so that means, based on my work here, that AD is congruent to BC. So show what you found. And then move on. One pair of sides are now congruent. We need that same pair of sides to be parallel. So find the slope of AD and then find the slope of BC. And you can just do that since it's on the graph by counting. What's the rise over the run from A to D? 2 over 1. Up 2, right 1. What's the slope from B to C or C to B? 2 over 1. And so that means that AD is parallel to BC. And what property did we use to prove that this is a parallelogram? One pair of opposite sides are what? Parallel and congruent. Again, it has to be the same pair. Now, when you get to the test, that's going to be a way you can prove it's a parallelogram, but you're going to have to go further and decide, is it a rectangle, a rhombus, or a square? And that's what 6-4 is all about, are the special parallelograms. Okay, so we're going to go there next. In your notes, the only thing you have left is there's a chart that lists those 6 ways to prove it's a parallelogram. Do you guys see that chart? Okay, and then just a reminder about something that might mess you up there. What does it say? Oh yeah, that you only need one of these ways, okay? Don't think that you have to have all 6 ways. As soon as you have one way, that's enough to prove it's a parallelogram. Okay, we're going to look at 6-4, and you need your property sheet out because we're going to look at 3 of our parallelograms. So 6-4 is about the special parallelograms. There's 3 special parallelograms. And we're going to list all our properties first, and then we'll look at some examples. So you have parallelogram in your notes. Then you have the ways to prove it's a parallelogram. Now you're going to list rectangle. And we're going to list the properties of a rectangle. And then we're going to list the properties of a rhombus. You can wait to write that down until we get there if you want. And then the last one we're going to do today is the properties of a square. So we're going to look at 3 more shapes, okay? And we're just going to run through these properties pretty quick, starting with their definitions. In your notes on 6-4, I'm going to change every one of these definitions, so you're going to want to change your notes as we go, so try to turn and follow with me. Does everybody see this page in your notes? 6-4, rectangle? Okay, would you agree a rectangle is a quadrilateral? Okay, but we're going to change it and be more specific. Not only is it a quadrilateral, but it is also a parallelogram. So a rectangle is a parallelogram that has specifically what characteristic? 4 right angles. So the definition for a rectangle, and again, we're always going to identify which one's the definition. The definition for a rectangle is it has 4 right angles. But here's the thing. 4 right angles is not enough information to prove it's a rectangle. I'm going to say that again. 4 right angles is not enough to prove it's a rectangle. You have to first prove that it is what shape? A parallelogram. So it is a rectangle if it has 4 right angles, if it is also a parallelogram. So one of the properties of a rectangle, and the one you're going to have to use first, is that it has all 5 properties of a parallelogram. So before you can prove to me it's a rectangle, you're going to have to prove to me that it's a parallelogram, and then you're going to go a step further to say, maybe it's just a parallelogram, but if it has 4 right angles, we can say it's a rectangle. Okay? So right now my rectangle has 6 properties. It's got all 5 properties of a parallelogram, and it has 4 right angles. And then it's going to have 1 more property. So the other property for a rectangle is... So in your notes here, here's the part that says it's a parallelogram. And the last property is the diagonals on a rectangle will be congruent. The diagonals will be congruent. So the length of BD will be the same as the length of AC. So it has congruent diagonals. Congruent diagonals. When I think about that, I think about it visually. In a parallelogram, since it's slanted, would you agree that this diagonal has to be longer than this diagonal because it's slanted? But in a rectangle, it's no longer slanted because all 4 of these are right angles. So now those diagonals are going to be the same length. So think about your picture visually to help you remember that. Okay? So there's 2 ways you can prove it's a rectangle. Either it's going to have 4 right angles or it's going to have congruent diagonals. But you first have to show me that it's a parallelogram. Okay, so on the problem we just did on the graph paper, if that were on the test, I would first show it's a parallelogram, and then I would go a step further to see, does it have 4 right angles or does it have congruent diagonals? Okay, how could I show that it has congruent diagonals on the graph paper? What would I use to show these lengths are the same? Distance. They have to have the same distance to be congruent, okay? How could I prove that these are right angles on the graph? What would have to be true about this line and this line? They'd have to be perpendicular, which means what would be true about their slopes? Opposite reciprocals. So we could show that the slopes are opposite reciprocals to show that we have right angles. Okay, so just keep that in mind. We'll talk more about that next class period. Okay, so that's rectangle. That's all there is. Move on to the rhombus. So I'm going to skip some examples and we're going to go to the rhombus. Oops, went too far. Here's the rhombus. Again, we're going to change the definition. It is a quadrilateral, but we're going to be more specific and say that it is a parallelogram. Okay, so moving on to my rhombus. Definition. It's a parallelogram that has what? 4 congruent sides. But again, it has to be a parallelogram. So if you try to prove that it's a rhombus, you're going to first have to prove that it is a parallelogram. So one of the properties of the rhombus is that it has all 5 properties of the parallelogram. Okay, so if I want to prove I have a rhombus, I'm first going to prove it's a parallelogram, then I might try to prove it has 4 congruent sides. On graph paper, how can I show that it has 4 congruent sides? Distance formula. Okay, and I'd have to do it 4 times. All right, it has 2 other properties for a rhombus. So if you look in your notes here with me, oops, I missed it. There it is. So we already said that it is a parallelogram. So that's already listed, that it has all 5 properties of a parallelogram. The next thing that's true about a rhombus is its diagonals will be perpendicular. The diagonals will be perpendicular. Perpendicular diagonals. So think about a rhombus here. If it has perpendicular diagonals, what does that mean? Those diagonals are going to form when they intersect. Right angles. Let's be even more specific. That means it's going to divide this rhombus into 4 what? Right triangles. And then you might have to use the things we learned last semester about right triangles, like Pythagorean theorem, or 30, 60, 90, or 45, 45, 90. Do you guys remember talking about all of that? So you might get a picture on your homework where they give you 2 sides of the right triangle and they want you to find this 3rd side, and you have to use Pythagorean theorem to do it. Okay, so don't forget the things we learned last semester. If the diagonals are perpendicular, they're forming right angles. On a graph, how could we prove that the diagonals are perpendicular? Say it, Brendan. Opposite reciprocal slopes. So we could find the slopes of these 2 lines and show that they're opposite reciprocals, and that means they're perpendicular. So if I want to prove that it's a rhombus, I first have to prove it's a parallelogram, and then I could either use distance formula and do it 4 times on the sides, or I could just use slope and prove that the diagonals have opposite reciprocal slopes. Would be a little faster. Is that okay? Okay, last property for your rhombus is each diagonal is going to bisect the opposite angles. I usually just write it as diagonals bisect opposite angles. Diagonals bisect opposite angles. So, I'm going to draw a rhombus here just to make sure you understand what we're talking about. If I have a rhombus, my diagonals are going to bisect the opposite angles. What do we already know about the opposite angles since a rhombus is a parallelogram? What's true about the opposite angles? They're congruent. So these are already congruent, and these are already congruent. So when I draw in the diagonals, they're actually going to split these opposite angles into 4 little congruent angles. Does that make sense? And then this diagonal is going to split these 2 angles into 4 little congruent angles. They're not all going to be congruent, but we're going to have 2 here and 2 here that are all 4 congruent, and 2 here and 2 here that are all 4 congruent. Okay? I want you to notice something else that ends up happening in your rhombus then. What's true about this little segment in these 2 triangles? What do you notice about this little segment in this triangle 1 and triangle 2? It's the same. So using reflexive property, would you agree that is congruent to itself? So then what do you notice about these 2 triangles up here at the top? Say it again. They're congruent. Angle, angle, side. What do you notice about these 2 triangles then doing the same thing down here? Congruent. Angle, angle, side. And because the diagonals bisect each other in a parallelogram, it actually turns out to be that all 4 of those little triangles are congruent to each other. Do you see that? That's going to be important when you're working through some of those problems. Okay, that's all for the rhombus. It has 8 properties. 5 from the parallelogram, 3 more properties, and lastly is our square. Square is going to be the easiest. So flip ahead to the square. Oops. And again, change the definition in your notes. It is a quadrilateral, but it is more specifically a parallelogram. Okay, it's a parallelogram with what? 4 right angles and 4 congruent sides. Okay, remind me, which shape has 4 right angles? A rectangle. And which shape has 4 congruent sides? A rhombus. So a square is a parallelogram and a rectangle and a rhombus. So a square doesn't have any extra properties, but it has all the properties. Sorry, it's going to search the web for parallelogram, just so you know. It has all the properties of a parallelogram, a rectangle, and a rhombus. So it has all the properties. So on your notes for square, you can just simply write down that it has all properties of a parallelogram, rectangle, and a rhombus. It has all the properties of all the shapes we've learned so far. Now, if you want to prove to me you have a square, that means you're going to first have to prove to me that you have a what? Parallelogram. And then in either order, you're going to have to prove to me that your parallelogram is also a rectangle and it's also a rhombus. So you can't say square until you've proven that it's all 3. So if you go back to that problem we did on the graph paper, we proved it was a parallelogram. When you get to the test, you can't stop there. If you've proven it's a parallelogram, you're going to have to prove to me why it's just a parallelogram. So you're going to have to rule out that it's not a rectangle and that it's not a rhombus, so therefore it's not a square. Or you're going to have to rule in that it is a rectangle and stop and say it's not a rhombus. Or you're going to rule in that it's both a rectangle and a rhombus, and so your answer will be that it is a square. Are you following what I'm saying? And we'll work some problems like that. But when you get to the test, it won't say, show me this is a parallelogram. It'll say, what is this? and you have to figure out on the graph using slope or distance what kind of shape it is. Okay? All right. So we only have about 6 minutes. The rest of this is just what we've been doing where you're applying these properties. So we'll do a few problems. I'm not going to make your homework officially due since we're not going to get finished with this section on Monday. However, if I were you, I would try to go ahead and do the assignment. You're going to have enough information, you can probably handle the rest of this assignment. But if you don't, if you have some questions, since we're not going to get through all the examples, I won't make it due until Wednesday. But remember, we're going to be reviewing on Wednesday, testing on Friday. So try to get your assignment finished, okay? So let's work a couple examples, and then I'll pass out the assignment. Am I saying the wrong days? This is Thursday, right? So it's not going to be due on Monday. Yeah, I said it right. It's due on Wednesday, test Friday. Okay. Okay, we're going to work at least one, maybe two. Look at this problem. Everybody with me? Okay. A woodworker constructs a rectangular picture frame. What's the key word here? Rectangular. Okay. Question is, what is HM? Looking for this little piece. They tell me JK is 50 centimeters, and they tell me that JL is 86 centimeters. How does that help me find HM if it's a rectangle? Diagonals are congruent in a rectangle. So if JL is 86, then that means that KM is also 86. So now we know KM is 86. How does that help me find just HM? Okay, we cut it in half because a rectangle is also a parallelogram and the diagonals bisect each other in a parallelogram. So we're going to divide that by 2. And so what is HM? 43 centimeters. Don't forget your units. So I hope you'll find the math isn't too hard, although just like the homework you turned in, I did throw in a quadratic on your homework. I'm going to keep doing that where you have to use quadratic formula or factor. But most of it's going to be pretty simple algebra, just solving. It's just can you apply the properties. All right, let's look at one more. And I'm going to go to the harder one. So I'm going to skip this one just to try to help you in case you're going to try to finish your homework. It might be more helpful if we do this one. So what's the key word here when you look at this example? And make sure you're looking at 2B, which is the one that says find angle VTZ. Okay, so it's a rhombus. That's important. We're trying to find angle VTZ, this angle. How are we going to find that angle, or what do we know about that angle if it's a rhombus? Say it again, Christian. Okay, perpendicular diagonals is going to come in to be important for this, even though that's not this angle. If the diagonals are perpendicular, what does that mean, this 14A plus 20, since it's pointed right here, what's that going to be? It's going to be 90, because the diagonals are perpendicular. So I could say 14A plus 20 equals 90. That's good to know, but that's not the angle I'm looking for. How will that help me figure out the angle I want to find, which is VTZ? If I find A, how does that help me find VTZ? Very good, Elijah. We also know that in a rhombus, the diagonals bisect opposite angles. So that means that VTZ is the same as ZTX, which is 5A minus 5. So if we find A, we can just plug it in here, and that will give us VTZ. Does that make sense? So if I subtract 20, 14A equals 70. Divide by 14, what do we get for A? 5. And then we can plug it in here again because the diagonals bisect opposite angles. That means VTZ is 5 times 5 minus 5, because we're plugging that 5 in for A. And what do we get for VTZ? 20 degrees. Now I went pretty quickly there. Any questions? Kind of lost? Not sure where I got that from. Okay. We will finish these notes on Monday. But worksheets again. This time I'm only giving you 3, so there's a front, back, front. Not a front, back, front, back. But I wouldn't say it's really shorter. Just saying. It just looks shorter. Some of these take a little bit more work. You will need graph paper. Make sure you have graph paper. Again, I won't count this late until Wednesday, but try to get it done by Monday. This is the homework, and I'll pass the slip back in just a second. I know. You'll be irritated next assignment when I pass out a slip that says it's the book, but that's all right. At least you had a couple days. That's right. Again, you don't really have to have this slip, but if you like to have it to kind of know what your assignment was, shift the worksheet. Yep. There's 3. Pass it back to the rest of the people.